Some animals seem to defy aging entirely, quietly outliving expectations in ways that still puzzle scientists. Among them are turtles and tortoises, which can live for more than a century, sometimes even longer in ideal conditions. It is not just luck or a single biological advantage, but a combination of biology, environment, and evolution working together over a very long time. So why do turtles live so long? In this video, we break it down and explore what allows their bodies to age so slowly, and why they last far longer than most animals of similar size and lifestyle. Right here, on History of Simple Things. Turtles are ectotherms, meaning their body temperature depends on the environment rather than generating internal heat. Because of this, they maintain a slower metabolic rate than warm-blooded animals. This slower metabolism reduces how quickly they burn energy and accumulate cellular damage over time. With lower energy demands, turtles can survive long periods without food during scarcity. Reduced metabolic activity leads to less oxidative stress, a major contributor to aging. Over time, this helps preserve tissues and organs in better condition than faster metabolisms. While metabolism alone does not fully explain longevity, it forms a key foundation for long-lived biology. It also supports other mechanisms that contribute to extended lifespan in wild turtle species over long evolutionary time periods today overall. Another major reason turtles live so long is their strong cellular maintenance and repair systems. Their cells are highly efficient at fixing DNA damage before it accumulates into serious biological problems. This slows the aging process at a cellular level and reduces the risk of early cell failure. They also show strong resistance to oxidative stress caused by reactive oxygen molecules produced during metabolism. In many species, oxidative stress is a major driver of aging, but turtles manage it more effectively. Their antioxidant defenses help limit long-term cellular damage and preserve tissue function over decades. This protection allows organs to remain functional for many decades without significant breakdown in aging studies. They are exceptionally resilient among vertebrates overall today. Evolution has played a major role in shaping turtle longevity through slow life history strategies. Instead of growing quickly and reproducing early, many turtle species invest energy into long-term survival. This reduces the biological trade-offs associated with fast growth and early reproduction seen in other animals. Protective shells also reduce predation risk, allowing individuals to survive longer in the wild. Because mortality rates are lower, natural selection favors traits that support longevity over short lifespans. Over millions of years, these traits were refined through evolution across turtle lineages, resulting in slow aging patterns seen across modern turtle species today in nature. This long-term evolutionary process explains why turtles age so differently from most animals overall today again. Turtle habitats play a significant role in their longevity due to stable environmental conditions. Many aquatic turtles live in environments where temperature changes are minimal and predictable. This stability helps maintain steady metabolic performance over long periods of time. Cold water environments can further slow metabolism, which may extend lifespan in some species. Even though turtles live in varied ecosystems, many still experience relatively consistent ecological pressures. Reduced environmental stress leads to fewer energy demands for survival responses and maintenance. Compared to animals facing frequent environmental change, turtles experience slower biological wear over time. Another key factor in turtle longevity is their slow growth and delayed maturity. Many species take years or even decades to reach reproductive age. This extended developmental period reduces physiological stress associated with rapid growth in other animals. Instead of investing heavily in early reproduction, turtles focus energy on maintenance and survival. This life history strategy favors endurance over short-term reproductive output in many species. Some species continue slow growth throughout much of their lives, maintaining steady biological function. This reduces overall physiological wear and supports long-term cellular health. All of these biological and environmental factors combine to produce the exceptional longevity seen in turtles. No single trait is responsible on its own, but rather a network of adaptations working together over time. These include slow metabolism, efficient cellular repair, and reduced exposure to environmental stressors. Together, they minimize the accumulation of damage that typically drives aging in most other species. As a result, turtles maintain functional bodies for far longer than most comparable animals. Researchers continue to study them because their biology offers insights into aging and longevity. Understanding their biology may help scientists explore how aging processes can be better understood overall. Turtles remind us that aging isn't always a fast or predictable process, and that biology can take very different paths depending on what a species is built for. Instead of relying on speed, reproduction, or constant growth, they survive through balance, protection, and efficiency over time. Their long lifespans are not the result of a single advantage, but the outcome of many systems working quietly together in the background. And while we still don't fully understand every detail of how they age so slowly, what we do know already challenges how we think about lifespan in general over time today. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.